So today we'll discuss about FTP, file transfer protocol. So yesterday we had discussion about HTTP. So your HTTP allows you to download, HTTP protocol allows you to download files as well. We download documents, PDF, whatever we can download, but FTP is a much more efficient way to do this thing. Okay, so we are here in the application layer. You can hear me, no? Yes, sliding on. So FTP is a much more efficient way to do this thing. So we discuss HTTP and then FTP. Then we'll now then we'll go to network security. Then discuss network security aspects, transport layer, network security, and the network layer, and then we'll come back to email, and then again go to back to network security in the context of email, PGP, and all those things. PGP, there is something called pretty good privacy, like that. So those things we'll discuss. So we'll jump between modules 5 and 6. Okay, that will be a very logical way to take the topic. So telnet we haven't discussed yet. We will see. We'll spend some time on telnet SSH later. So telnet and SSH are most likely candidates for short answer type questions. Do have a look. If we don't cover, you will have to look at. Okay, so it's the problem with the file transfer is that there is heterogeneity when two systems they try. There is a difference in the naming conventions. There is difference in the formats used to represent the data. The file listings, the directory structures might be different. So FTP is a very simple solution to do this thing. So what they do is that it isolates both the command, the control section, and the data transfer section separately. You don't mix them up, rather you keep them separate. So some commands, control commands are exchanged, and then you set up a separate you set up a data transfer path. So that is the format. So the basic model is that you have a client and a server. The client has three set of things, you can say three set of say client is requesting some access from a remote server. Okay, the basic so you have a user interface, for instance FileZilla. There is a client side software as well as a server side software. FileZilla is a FileZilla, just like Mozilla. There is a FileZilla. FileZilla is a FTP client with GUI. Earlier days the FTP used to be command line based. Now lot of them, WinSCP, all those things, several tools are there. So these are having GUI interface, so that is much more convenient. So there is a user interface, it could be command line or GUI. Then there is some control process which is running, which is making a virtual connection to the server, the control process running on the server side. Okay, so and again there is a data transfer process running on the client side, which is making a data connection with the data transfer process running on the server side. So these three. So that's a separation of commands as well as data connection. So this control connection is fully concerned with commands, say whether to authenticate a user, then to initiate the transfer, abort the transfer, all those things, putting checkpoints, all those things are done in the using the control commands. Whereas the data transfer is concerned with purely the data transfer. And a thing to notice that it is a client that determines the lot of parameters of this data transfer. Okay, so this control connection will be admit. Okay, So control connection exists throughout. It is existing during the entire duration of this file transfer, and multiple data transfer sessions may take place during our during this control connection which is set up. Okay, so for each file transfer, data connection is opened and then closed. Suppose you have multiple files, and but the control connection remains active throughout this. Only once you close the client or end it using a command line, it just stops. So the port 21, TCP port 21 is used for control connection and 20 for data connection. This is to be remembered. ഇപ്പോൾ കുറേ അധികം പോർട്ട്സായി, കുറേയധികം പോർട്ട് നമ്പേഴ്സായി പഠിക്കുന്നു. അപ്പോൾ അത് ഓർത്ത് വയ്ക്കുക. പോർട്ട് 21 for control connection and port 20 for data connection. Alright. Again, so control connection is basically the client server model. Some requests, in the sense request, it goes as commands and responses, requests and commands. So commands and responses, that's the thing. So for control connection, it uses a NVT ASCII character set, and so you see some of these commands. These are in uppercase, which may have an argument or may not have an argument. So user, so this is user. So these are categorized as data access commands. There is a whole set of commands. So but you just remember at least one or two, say one or two of these things. So I just listed up the things which will be much more easier to remember: user, password, account, reinitialize, quit, about the previous command, like that. Okay, so this is achieved through commands and responses, right? So control connection, each of these control connection will generate a response. So that is, you sending a command from the client side, and then you will get a response. Response will be in the form of a 3-bit 3 digits. So so this have different meanings, that is understood. So so some 125, then there is 200 command OK, then 220 service ready. So you remember at least one or two of these. Okay, user not logged in, user login OK. So these are authentication set. So all this 2 refers to user login related things, something like that, the initial parts. Okay, there is again 331, user name OK, password is needed. So the numeric status of the command is defined by the first digit, area in which the status applies, that is, and the third digit provides additional information. So that is the control connection description. So a response from the server side, you get a response. Now data connection uses the port 20. You remember that port 21 is used for control connection, and data connection uses port 20. So and the steps in this data transfer. So first a control connection is established, you authenticate the user. Once that is over, the data transfer can take place. So it will open a passive, it will use a temporary port number, a passive open using a temporary port number, and this will be sending this port number to the server, and server receives the port number and issues an active open. So that is the way in which the data transfer will take place. So all these things, the file type, different file types are there. You could have files, records, directories. So you could all those things are defined by the client. The default one is file. So just it's a stream. It could be transmission mode, it could be stream, it could be compressed, it could be burst mode type of data. Different types of transmission modes could be there. All these things are determined by the client. Okay, so client will define what type of format has to be done, format the data transfer has to take place. So what do you say, you will define these three parameters, the client will define these three parameters, because the naming conventions, the data modes, all those things will differ. The client is given the client is given the task of what do you say, transferring. Client is given the task of mentioning it prior as to what is the format. File type, it can be what do you say, ASCII file, EBCDIC file or image file. Data structure, it could be a file structure. File structure is the default one. File structure is a default format. And the records, it could be stored as records, or it could be pages. So pages will have an end of page. So that matters. So all those things had to be specified by the client. Then it could be transmitted in a stream mode. Default is a stream mode, just like a TCP stream. Or it could be in a burst, a block, or it could be compressed. Any of these modes can be used for transmission. So basically the transfer occurs over the data connection under the control of commands sent over the control connection. So that file transfer can imply three things. One is retrieving a file, that is from the server to the client, storing a file that is from the client to the server, or even listing the directory. So some of these this things are enough for FTP. We are not going into details about the commands or anything. So these are some common what do you say, FTP clients. FileZilla is the best one. WinSCP is also there. This is CoolDuck something. So Seahorse, some so you could use any of these clients. So we'll discuss about network security. So network security is a topic which is affecting all the layers. It is not specific to a particular layer. So we'll discuss all the, it's a comprehensive thing. So we'll discuss in particular about network security in relation to IP layer security, information security with related to IP layer, then that is the network layer. Then we'll go to transport layer and also application layer with specific focus on email. That will be that is what the thing is. So we'll first discuss the general thing, then we will move on to IPsec. IPsec is a set of protocols which is proposed by IETF. So we'll discuss about IPsec. IPsec in the tunneling, VPN, all those things. So we won't go in depth about those things. We'll just tell what is this tunneling, all these things, and virtual private networks. We'll make a reference about that. Then we'll go to transport layer in the context of how the TCP could be made more secure. And then we'll discuss about email, and then again come back to this security in the context of email, PGP and all those things. Okay, so the basic the three goals. So information, the basically is that information is valuable and it has to be protected from attacks. There is one aside, we have to say that there is no perfect security. There is no absolute security, is not possible. There will be some loopholes somewhere. So these are the three goals. One is confidentiality, then integrity and availability. These three things are key aspects, key goals of information security. you have to prevent access by unauthorized users, and authorized users have to be permitted. That is what the availability has for instance say unauthorized access as well as non-availability of information is also a problem. Non-availability of information, for instance, you are trying to check your bank balance over a mobile app or internet banking. You are trying to take a statement, you are not able to get the information. That is the non-availability. That is also a problem. You are an authenticated user, you are an authorized user, still you are not getting the information. That is also, availability is also key there. Then integrity of this information. You just like protecting it from unauthorized access, you have to ensure that this is not changed by unauthorized people. So the situation was very okay when information was stored on a single computer, but the computer networks, they have added another dimension to this whole thing of information security, where your information is distributed. It is not stored on a single computer, rather it is stored in multiple places. It's duplicated, and you can access that, so you can say that it's distributed, and it can be accessed by authorized users from anywhere remotely. Authorized as well as unauthorized users from anywhere. You need not be physically present near the on site where the information is. So that's the so all these three goals still are to be fulfilled when you in computer networks, the information security in the context of computer networks. So so these are the broad classification of security attacks. Say you have threats to confidentiality, threats to integrity, and threats to availability. These are three broad classifications. You are aware of most of these things. Okay, you are aware of most of these things. So so that is snooping. Snooping is unauthorized access. That's what. So the best way to prevent snooping is you use some encryption, cryptographic algorithms to encrypt it from at the source, and then at the other end it can be decrypted. So there will be we had seminars on public keys and private keys and also all those things. So that is one way. Using digital signatures, all those things are authentication things. So anyway, this is snooping as unauthorized access. So you prevented snooping by encrypting it. There is still a scope for traffic analysis. Say very clever people will sit and analyze your traffic. You can use tools like Wireshark or similar tools are there, Ettercap, like that. A host of tools are there which could be used to get additional information. For instance, the email ID, then that could be used for phishing purposes. You could infer a lot of things about the sender's name, all those things, by this traffic analysis. So there are automated tools also to dump you data, about give you dump of the data which is being monitored, traffic which is being monitored. So such things are there. You needn't sit there and analyze it, but rather there are automated tools to do these things also. These are network network security testing tools. These are often available as network security testing tools, but they have good as well as bad uses, both. Again, integrity, attacks threatening integrity. There is a modification of data, so that's possible. Then masquerading is impersonation. So you say you impersonate as someone else. you send an email as some other person. So this lockdown time, our college is getting lot of emails. The faculty is getting emails from the principal, from the HOD, telling they need a help. I need a favor. Single line. I don't know why these people don't change the email body. Always the same thing. I need you. I would like you to do me a favor. Same thing comes always. Then replaying is that say you gets your attacker, he gets a copy of the message, and for instance you say you were supposed to be paid some money from a bank, and you got the payment. The attacker is getting the message, and he might replay this message, send it to the bank again, telling that you haven't got the payment again. So that is one way of repay. And repudiation is denying. So basically we say that I didn't see that message, or I didn't get that message, or I didn't get the payment. So one of the parties involved in the communication, they will say that didn't take place. So repudiation is basically a threat to the integrity of these things. So, and again availability attacks threatening availability. There is the denial of service attacks. Denial of service attack is a very common attack. So it will slow down or totally interrupt the system. So there is DDoS, distributed denial of service attacks. There are bots which are used to do this, carry out those things. So several strategies are exist. Basically for genuine users, you won't be able to access the site. You will get multiple requests. Your server will get bogged down with all these requests. So and the site will become unavailable. So such things are there. So that's the basic idea behind this. So we'll discuss about security in the network layer, and it's called as IPsec. So IPsec. I'll just close this slides, the previous ones. Okay, so we are all aware about the TCP/IP protocol suite. We are in the network layer. So the lower layers we just don't bother. Physical security is always ignored. It's an ignored aspect. What is the easiest ways to access a Wi-Fi for which you don't have a password? What is the easiest way to access a Wi-Fi if you don't have a password? People are there simply sitting. I don't know why. Okay, so yeah, default router password is a one way. Get there, admin blank. Dealing angle, you can just note the model number, go there, or just physically you don't protect much of these devices. Or if WPS is enabled, you could use it. That is also possible. WPS which accessible angle, yeah. Physical security is often ignored and lot of things. So anyway, this security of the network layer is has been dealt by this IETF. We discussed about IETF later, Internet Engineering Task Force. It's a task force, it's involving experts, worldwide experts in this, who contribute to this various aspects related to internet. And it's a not-for-profit thing. So they have designed a set of protocols, which is to provide security to the network layer. So that is, you are aware that the network layer is having a function of routing. So routing protocols, all those things run in the network layer, so they have to be protected. You have IP, internet protocol running on the network layer, so all those things have to be protected by some some protocol, some mechanism, so that's provided by these things, IPsec. So it is basically providing some sort of confidentiality as well as authentication, so for the IP layer. So there are two modes of so this is a screenshot from a YouTube video. Okay, that's why this pen is seen here. Okay, so this two modes, one is the transport mode and another one is the tunnel mode. As you see here, the transport mode is an end-to-end protection, provides end-to-end protection between two hosts, whereas your tunnel mode is in between two gateways, say between two routers, like that is a tunnel. This is how this is one way in which your virtual private networks operate. So either your transport mode is there or tunnel mode. These are two modes in which IPsec operates. Okay, so that's the transport mode is what it is. If you recollect, you have the application layer, transport layer, network layer. So transport layer payload is called as a segment, and it is given to the IP layer, and so this IP layer will add its payload. Okay, it will be just protecting the payload only, it won't protect the IP header. That's what this is, the network layer IP, the default the usual header in the IP. Okay, so and this IPsec layer is going to add a header and a trailer to this transport layer segment, and that is forming the payload of the packet, which is formed in the IP layer. So that is protecting only the payload, it doesn't protect the IP header. Whereas we see in so this is how it operates. So this is an end-to-end protection. The two host A and B are there. The transport layer payload is encapsulated within IPsec header and trailer, and it is passed on to the network layer, where it is forming a IP packet, and it is sent over this physical link, and finally it gets to the other end, where it is decapsulation process takes place. And it is delivered to the transport layer. So we have simplified a lot of things here. We are not mentioning about encryption, authentication, decryption. All those things will come later. Okay, so that things we'll discuss in the next class. Okay, so again, the tunnel mode, it is protecting the entire packet. If you see, compared to the other case, here you have the payload coming from the network layer. It is protected with its IP. Both these go into the IPsec, which is encapsulated between IPsec header and trailer, and it is forming a new network layer data unit, and it is transmitted. So so it will add a new IP header also. That is the way in which this process it's used between two hosts, host and a router, or between a router and a host. So it's a virtual private network. So you are transmitting the network layer data unit, and the new network layer is there. It is transmitted with an IP layer which is added, and it is tunneled. Okay, So there are, next day we'll discuss about these two protocols. So one is for authentication and authentication header protocol and encapsulation security protocol. These will provide authentication and also encryption, okay, for the packets at the IP level. So today we wind up.